All right. Yesterday we talked about box and whisker plots and how to find them. Remember, it's just the median of the entire set of data, and then we will take the median or find the middle term of the lower half and then the middle of the upper half. Okay, or what we call is the upper quartile and the lower quartile. So remember, and we talked about this, the box is going to represent half of the data. Okay, each whisker or the line part, the whisker is going to represent a quarter of the lower and a quarter of the upper. Okay, it's like whenever we've talked about like the EOC, you have below basic, basic, advanced, and proficient. Okay, your advanced is going to be on that upper, that higher quarter, and then you go down to your proficient, then your basic, and then your below basic. Okay, it's basically like we're just splitting it up into fourths. So your other measure of variation that we have is what's called the interquartile range. All that is the value of your third quartile, which is right here, and your first quartile. Okay, or your upper quartile minus your lower quartile. Okay, remember when we found the range of our data, we took the highest number and we subtracted it from our lowest number. Or we subtracted our lowest number from that. You're going to do the same thing, but now we're going to take our third quartile and subtract our first quartile is all we're going to do. So whenever we interpret it, it says the box and whisker plot represents the length in seconds of songs played by for teachers, yep, buy one, get one. Songs played by a rock band at a concert. Okay, so the highest value is 300 seconds for a song. So the highest value was 300 seconds. The shortest song was 160 seconds. So where would, basically, it says find and interpret the range of the data. So all I'm going to do is I'm going to take I'm going to take the highest value, which is 300, and I'm going to subtract 160. So the range is 140 seconds. So a little bit over 2 minutes. So then it says describe the distribution of the data. So where is most of, like, is it even basically across? Like, is it evenly spaced? No. Where is the majority of your data actually at? 260 and above. 260 and above, right? Okay. So because of how it's separated, the bulk of your songs are really in this shaded area right here. Okay? Because it says a quarter of your songs are going to be between that 260 to 280. Okay? Because, or even if we look at it this way, that over half of your data, see how it's so much shorter than the back half that is back here in blue? So the bulk of the music that's getting played here, okay, is really between 260 seconds and 300 seconds. Okay, because it's really packed in. Okay, so the tighter it is, the more values that are in there. Does that make sense? Okay, because we're chopping it into halves and quarters, right? So half of your data is all squished in there for 40 seconds, basically. Okay, the back half is basically is 100 seconds of a range, kind of, if you think about it that way. So the majority of the songs that they're going to play are probably in that 260 second to 300 second range. Okay, because it's really packed in there. So the tighter that your window is, the more of those types of values that you're going to have. Does that make sense? Finding the interquartile range, we're just going to take the lower quartile and the upper quartile. So my 280 that I have here and my 220, okay, the ends of the box, and I'm going to subtract those. So 280 minus 220, 60 seconds. Half of my data is only 60 seconds apart in songs. You all have songs on your iPod or your MP3 player, or you listen to satellite radio or whatever. Most of the songs for most artists are probably about the same, right? Now, every song is not 3 minutes and 33 seconds, but they're probably within that 3 to 4 minute range, right? Okay, I would guess, okay, depending. Now, there are other songs that are really long, and there are other songs that are really short, okay? So it says, for D, are the data more spread out below the first quartile or above the third? So it's really simple as far as that question's asking. If it's spread out, which one's more spread out?
Before 1.
Yeah, before 1, right? Because it's a longer line. Okay, it's really, don't overcomplicate the question. If it's spread out, the longer the line, the more spread out your value. So, below 1, wrong one. So below 1 is where it's spread out. So below Q1. It's kind of opposite of what you would think whenever we compare. Symmetric should probably be the easiest one of anything because it's pretty evenly matched. Kind of top to bottom or left to right, however you want to look at it. Whereas if it's skewed left and if it's skewed right, really it's like, think about it this way, whenever we talk about it being skewed, if it's really packed in on one end, it's going to be skewed the other way. Okay, it's kind of opposite of how you would think it looks. So wherever it's a lot longer, okay, do you understand that on this back end that it's skewed left, that the left side is longer or bigger than the right side here? Okay, it's really pulling it on one end to the left, whereas on the one on the right, it's really pulling this end as opposed to the left end. Okay, whichever half is longer or more spread out, that's how it's going to be skewed. Okay, that's the easiest way to look at it. Now, if it's pretty even like it is with symmetric, then it's symmetric. There's really not anything that's spread out on the lower end or the upper end. And the last part. Yeah, like which way would it be skewed? So like here it says your friend's class is in red and your class is in blue. What would you say about your class? Is it skewed left or right? Is it pretty symmetric? But even figuring in that, okay, which I agree with, that's probably a good statement. Okay, so like for Parker said that it's pretty symmetric, but it has an outlier. Let's still figure that outlier in there. Okay, so even if it's, so here, our class is going to be skewed left, or your class is skewed left. What about your friend's class? It's symmetrical. Where your friend is symmetrical. Now for B, it says which test scores are more spread out? Your class or your friend's class? Don't overcomplicate it. Here's your friend's class. You both have somebody that got 100. They have somebody that got a 60. Your class has somebody that got probably like a 68, something like that, 67. So whose class is more spread out? Theirs. Okay, your friend's class. What was the lowest class score? What was the lowest score between the two classes? 60. Which class? Your friend. Which class did better, yours or your friend's? Yours. Why?
Because most of the percentages are over on the right side, the top, like most of the kids, while the others is more spread apart.
Well, think about it this way. The median here is at 90. That means half of the kids scored a 90 or above. Okay? Even though you had somebody down here that maybe didn't show up to class enough and they got a 67, or they only showed up part-time, maybe had 30, 40 absences, something like that.